All right, guys, so we have our notebook. We hopefully already set it up. Syllabus in the front, first divider with our first topic. We're going to be talking about foundations for algebra. So hopefully a lot of this feels like review for you. Hopefully pretty basic concepts. And so if we turn the page there, we are going to fill out our table of contents. So for the first topic that we're going to talk about is we are going to talk about different types of numbers. So I'm going to call this number types. And we're going to do that just on page 1. So like that. And then on page 1, which is going to be right across from this, I'm going to label it as page 1. And we want to get from our packet of stuff, the handout that I gave to you guys at textbook distribution. It should be the very next page that you have. Along the side, it says number types, and it's got this looking thing. And this is a super simple way to fold this one. Right along this line here, we're going to have this edge meet over. So kind of like folding a backwards book. And just so that words don't get cut off over here, I'm going to fold it actually a little bit past that line. So just like that. No cuts or anything. Sometimes we'll need scissors to cut. And then you can just glue or tape that in. So I'm going to tape mine in just because it's quicker. We'll roll of tape on. Oh, that's just annoying. My roll came unrolled. Let's try again. Little roll of tape. And then right underneath page 1 like that. Okay. And normally I would fill out the front with you, but I think I actually want to leave that for you to try. So, but I am going to look at it with you really quickly and talk a little bit about numbers. Now, this is kind of super mathy, and I geek out on it because I love math. And when it comes to the very basics of math and just talking about numbers, we can talk about numbers in different types of ways. And what type of number they are. Kind of like in English, some words are nouns and some words are verbs and some words are adjectives. And I really can't tell you the difference because I'm not an English teacher. The same thing is true for numbers. Some numbers are a certain type of number, and other numbers are other types of numbers. So you might want to think about what numbers, so specific examples, could best describe these things. So the temperature outside in degrees Fahrenheit. Now, as a really quick example, I'm going to have you try more of these, like I said, after I go through it. The temperature outside right now is cold, but that's not a number. We'd want to do like it's 61 degrees outside. That would be a specific example. And then kind of once we have a list of numbers, then we can classify it by its type or its name. So that's where we get into the inside here. And these are different types of numbers. Now I'm going to use a little bit of color. So if you are able to and you would like to, feel free to join me and use some color here. So all numbers that you know of so far are real numbers. So we have real numbers that make up all of the numbers that you could possibly think of. All the numbers that you see here, any of the numbers that you write on the front here, those are all real. You don't know any non-real numbers yet. And I say yet because you will. And then once we have real numbers, they can go off into 2 different categories. So at that point, you have to make a choice with your number. Either your number is irrational, and I do that in red because irrational numbers are kind of kooky, or you are rational. You can only be one or the other. You cannot be both. Okay? And so what it means to be a rational number, the word rational itself means written as a fraction. So any number that can be written as a fraction is a rational number. So for example, one of my favorite rational numbers is 2/7. not quite sure why. I do love fractions, and the number 2 and the number 7 make up my birthday. So maybe that's something to do with it. But another rational number could be something like -2 or 0 or 7. Or, if you remember this, even numbers like 0.3 repeating. I can write 0.3 repeating as a fraction. There's like a process that you can follow to do it, but I've done it so many times that now I just kind of remember that 0.3 repeating is 1/3, but those are rational numbers because they can be written as fractional numbers. Now, an irrational number, oh, sorry, that was my hair, cannot be written as a fraction. And one of the most famous irrational numbers is a number that goes on and on forever, does not repeat, and cannot be written as a fraction. And that number is pi. So pi is kind of the most famous irrational number. But there are lots more irrational numbers. Irrational numbers kind of happen in between really nice numbers. So another really good example of an irrational number is something like the square root of 5. And I say that because I know the square root of 4 is 2. But then if I think of square root of 5, I don't know it. Square root of 6, I don't know it. Square root of 7, don't know it. Square root of 8, don't know it. But square root of 9, I know it, and it's 3. So kind of in between the 2 and the 3, or the square root of 4 and the square root of 9, are all these other square root numbers that I just don't know, like the square root of 5 or the square root of 7 is another really good irrational number. And you can toss a negative in front of it and you have a different type of irrational number. Same with pi. You can toss a number in front of pi, 3 pi. That's still irrational. Another really famous irrational number that you'll learn lots more about in Algebra 2 is another number like pi that's represented with a symbol. It's called the letter E. Now, irrational numbers are weird and we don't like to live in that space so much, so we're going to kind of let those be. Now, if I'm a rational number, I could be even better than that and not deal with all the fractional numbers because I know you love that. So if you're a fraction, you're just rational. So it kind of splits off here. All the fractions go this way and they're just rational numbers, but I might be better than that and I might be an integer. Oops, actually I did that the wrong way. I wanted purple here, but that's okay. So integers were kind of the numbers that you learned probably in like, I don't know, first or second grade. Probably second grade is when you learned about negatives, but integers are all the nice numbers that you pretty much like dealing with, but also the negative ones. So like from negative infinity all the way up to like -3, -2, -1, 0, and then into the positives 1, 2, 3, and so on forever in both directions. Those are all of your integers. So they're all the really pretty numbers with no decimals, no fractions involved, but we have positives, negatives, and 0. Okay. Now, you can simplify that even further because at one point, you didn't know that negative numbers existed. Now, negative numbers on their own don't have a classification. They would just be considered integers, but whole numbers is another sort of classification, and whole numbers are non-negative numbers. So the numbers 0, 1, 2, 3, 4, so on and so forth. So whole numbers are super nice because you don't have to deal with negatives. And for a while, that's kind of all we needed because who needs negative numbers? Unless we're talking about temperature, right? Because eventually it's going to be -10 degrees outside and hopefully we get a cold day, if that's even a thing anymore. Oh my gosh. Oh. Now, last but not least, we can have one other type of classification because as maybe as weird as it doesn't sound, 0 is kind of a weird number because, I mean, it represents nothing. So positive numbers or numbers greater than 0 are called natural numbers. And I hate that I forgot my other parenthesis right there. So once I chop off the 0 and count up, they're all my counting numbers. So 1, 2, 3, 4, so on and so forth forever are natural numbers. Now, when you're writing a classification of a number, you want to pick the best name that it could be, and then it is all the other things above it. So if something is a natural number, it is also a whole number and an integer and a rational number and a real number. Now, we don't really need to call things real numbers because that's the space we're living in. If something is irrational, it's just irrational. If something is an integer, let's say -7, it's an integer, but it's also rational. Integer is just its better name. So if we go through these kind of quickly, 32.45, now maybe that seems like a weird number, but I could write that as a fraction because I could say 32 and 45/100ths, which now I'm in fraction land. So that means that this is a rational number. And then I just want to think about, can it be any better than that? Now, it can't because it can't be an integer. It has a decimal after it, so it's kind of living in fraction land over here. So the best we can get for that is rational. I didn't need a comma. Oopsie doops. Now, this next one is interesting. Pi over pi. Now, instantly my students, whenever they see pi, they're just like, oh, irrational, done. But pi over pi, or pi divided by pi, or anything divided by itself is just 1. So really that simplifies to 1. And the best name for 1 is actually a natural number. So this is natural. But since it's natural, it's actually also whole. And it's an integer because it's under that branch. And it's rational. So it's got a lot of names. Its best name is always the one I list first, and then all the ones that come above it. So next we have the square root of 5. Oh, shoot, I took that example over here, but I do not know the square root of 5. If you type it in on your calculator, it's a nasty decimal that your calculator will chop off, but it's only chopping it off because it can't spit it all out at you because it doesn't know it, and it would be doing that division forever. So this is irrational. That's the only thing irrational can be. Now 23 is a positive number with no decimal or fraction after it, so that is natural. And just to save some time, since this one's natural and number 2 was natural, it's got all the same classifications. Like if you're natural, then you are whole and integer and rational as well, always. Now, -5/6, that's a fraction, and it can't get any better than that. Like it can't be an integer because 5 does not go into 6, or 6 does not go into 5 rather. So the best we can do here is rational. We can't classify any further because that's living in fraction land. Okay, same thing here. We are rational because that is living in fraction land. The square root of 36. Now we don't want to be too hasty here. We want to think about, can I take the square root of 36? And I can. A square root is what number times itself is that number, and 6 times itself is 36. So since I can actually reduce that and make it 6, the best classification for 6 is a natural number. So again, because this is natural, this one is a lot like number 2. So it has all those same classifications. Now, if that was the square root of 37, can't do it. Nasty fraction, or not nasty fraction, nasty decimal that never ever ends. So that would be irrational. -8, let's see, that is a integer. I can't do any better than that because it's not whole or natural, and negative numbers don't have their own name. But since it is an integer, it is also rational and real. The negative square root of 2. So I have to think about, can I take the square root of 2? What number times itself is 2? And there isn't such a number. And even though there's a negative in front of it, irrational numbers are simply irrational, and that's all. And last but not least, anything with pi on it, pi is irrational, so irrational. Okay, so hopefully we took good notes here. If you need to pause, go back, whatever, that's fine. What I would love for you to do is actually think of some numbers that you could fill in here and then name that type of number. So if people in your family is irrational, then that would be the best name for that. I don't think that it is. And then take a picture of this and attach it so that I know you watched the video. All right, hopefully that wasn't so bad, guys.